Hi folks. Kind of continuing building on from our last lesson, we're now going to learn how to solve inequalities using multiplication or division. And just like addition and subtraction, this more or less follows the same rules that we followed when we were dealing with equalities, equations. But they do get a little more complicated here than with addition and subtraction. So the multiplication or division property of inequality says that if you multiply or divide each side of an inequality by the same positive number, you get an equivalent inequality. And you can probably see what's coming here. Same positive number, well then what happens when you multiply by a negative number? When you multiply or divide each side of an inequality by the same negative number, you reverse the inequality sign in order to keep an equivalent inequality. So I'll show you what this means. I'll show you where it comes from as we work through some examples. So let's look at example 1. X divided by 8 is greater than negative 5. In order to solve for x, in order to get x all by itself on one side of the equation, I need to get rid of that 8. Well, this is x divided by 8. So to get rid of the 8, I need to do the opposite. I need to multiply this side times 8, and I need to multiply this side times 8. So then I end up with those 8's canceling out, and I have x is greater than negative 40. And this was a straightforward example because we were multiplying both sides of the equation by the same positive number. So let's look at what happens when we have a negative number that we want to get rid of. And first I'm going to approach this using the skills we learned from the last module, from the last section of the textbook, using addition and subtraction. So if you look at this example here, if I add 7y to both sides of the equation, I cancel out the negative 7y on this side, and I'm left with 0 after doing that addition problem. And on this side, I have negative 35 plus 7y. Well, now I want to get rid of the 35. I'm trying to get y all by itself, so I'm going to add 35 to both sides of the equation. And when I do that, negative 35 plus 35 is just 0, so I'm left with positive 7y on the right side and 35 on the left side. And if I divide both sides by 7, then what I end up with is 5 is less than or equal to y. Let's look at doing this a different way. Let's look at this using multiplication of a negative number or division of a negative number. So here I have negative 7y. So you may have asked yourself, well, if it's negative 7 times y, if y is being multiplied by a number, why don't I just divide that number away and see what happens there? When I divide both sides by negative 7, I have y on the left side of the inequality, and I have, let's see, negative 35 divided by negative 7 is positive 5 on the right side of the inequality. Based off of everything we've learned so far, you probably want to copy that less than or equal to sign exactly as shown there. However, look at this relationship that we ended up with the first way we tried to solve this problem. 5 is less than or equal to y. The 5 is on the small side of the inequality, and the y is on the big side. That means that the actual relationship, the y is on the big side and the 5 is on the small side, this is the correct representation after we divided by a negative number. Notice what happened to that inequality sign. It got flipped. It went from less than or equal to greater than or equal to. And this is what you need to remember whenever you multiply or divide by a negative number. This is something that students forget all the time. They forget to flip that inequality. Therefore, I recommend to my students that they do things by addition. It does take up a little bit more space, but you're never going to make a mistake. You're never going to forget to flip the inequality sign. When you multiply or divide by a negative number, you might forget to flip the inequality sign. So that's just a recommendation that I have for you so that you don't forget to do a step and end up getting it wrong. Looking here, how do we graph this solution on the number line? Remember, in terms of these two versions of the equation, this one is easier to graph. So y is greater than or equal to 5, which is here, and then we shade in the arrow over here to the right. Let's look at a real-world example of an inequality. So you save $150 each month to buy a mountaineering suit that costs $1,249.95. Use an inequality to describe the number of months you must save to afford the suit. So I'm trying to save $1,249.95, and I can save a certain amount each month, 150, times the number of months that I work. And of course, this money that I save needs to be greater than or equal to the cost of the suit. If I have less than, I won't be able to purchase the suit. So how do I go about solving this inequality? To get m all by itself, m is being multiplied right now by the 150. So I want to divide the 150 away, and I'm left with m is greater than or equal to 8.333333. I don't get paid every third of a month or every quarter of a month. I get paid monthly. So if I'm actually trying to answer this question, how many months do I have to wait if I'm saving up to buy this suit, then I would have to wait 9 months. So once again, let's have a look at our procedures here, how we go about solving these equations. Any positive multiplication or division done to one side of the equation can be done to the other side, and the inequality stays the same. The sign stays in the same orientation. If you do any negative multiplication or division to both sides of the inequality, you have to flip the inequality sign. But that's something that students often forget to do, and therefore my recommendation is to move any negative x values that you have to the other side of the inequality using addition, like we did in this version. We added 7y to both sides of the equation so that we would end up with 7y on the right-hand side. I hope this helped.